last part of chapter 9, which is called, a chapter on circles, is actually parabolas, which aren't circles. But what we'll see in a minute is that you can make equations for parabolas that are very similar to the ones for circles. So a parabola looks like this, and you actually dealt with these last year in algebra. What you would need is a vertex, and that's going to give you most of it, right? Kind of like the equation for circles. When you wanted to write an equation for a parabola last year, you just needed sort of like the x value of the vertex, which in this case is 3, right? Because in this graph that I'm using here, every 2 boxes is 1. So there's 1, 2, 3. So the x value would be 3. So if I'm writing the equation for this parabola, it would be x minus 3 squared plus the y value of the vertex, which is right here at 2. Then there's this number out here, this coefficient called a, and a most of the time, well, we start off assuming that a is 1, unless the parabola is widened out or made more narrow than just sort of your standard parabola. So if I put a number less than 1 right here, between 1 and 0, the parabola is going to widen out like this blue one. If I put a number greater than 1 here, the parabola would get skinnier. And this is all review from last year. And so what we're going to do today is we're going to learn a new way of graphing parabolas. So if I wanted the equation for this one, I've already done it up here. And why does a stay at 1? Well, because if I erase these other two, basically what we would expect is every time I increase x by 1, so if I make a little table here, if I go increase x by 1, y should increase by 1 squared. So 1 squared is just 1. If I go over 2, then y should increase by 2 squared, which is 4. So 1, 2, 3, 4. And that's what the parabola here is doing. If I go over 3, y should go up 9. Well, I can't see that, but you can just take my word for it. So basically here, the coefficient would just be 1. And since it's 1, I could just leave it off. But again, if I put a number in front there, if I was using some sort of graphing program, if I put a number out in front here that was bigger than 1, the parabola would get narrower. And if I put a number here that was smaller than 1, or actually between 1 and 0, the parabola would start to get wider. But again, we're going to learn a new way to graph parabolas today. And this one is actually more relevant to how engineers and scientists use parabolas in the real world. The reason we think about parabolas at all, at least as I understand it, is, or I should say maybe the best sort of way to think about how parabolas are used in the real world is through satellite dishes. And so I'm going to sketch kind of a crummy satellite dish here. And what you'll notice is that there's not only the dish, but usually there's this antenna thing kind of sticking out of the middle. And so on any satellite dish, you'll see there's this piece here, this antenna-like thing, that's, I think, usually called like a receiver. And so if I took this satellite dish and kind of just looked at it from the side, right, and here's the antenna thing with the receiver on the end, you can see that the dish itself is shaped kind of like a parabola. And the reason it's shaped like there, and the reason this thing is out here, this thing is called a receiver because it's what receives the signals. So there are these signals coming in from all different angles, and satellite dishes are designed so that when this signal comes in, it bounces up to the receiver. So no matter what direction the signal comes from, it's going to bounce off the dish and go up to the receiver. So there are all these waves coming in, and that receiver thing is what accepts the signals, translates it, or sends it to your TV or your stereo or whatever to translate it into something that you can watch or listen to. And so that's sort of the form that we're going to use today to talk about parabolas. There's this thing called the focus, and that is where this receiver is on a satellite dish. It's where any signal, wave, whatever, coming into the satellite dish gets reflected. It's kind of where they all become focused. Okay. Here's the new equation form that we're going to use to talk about parabolas. Some new parts. The directrix, that's this dotted or this like dashed blue line kind of below the parabola. And the way we describe it is with an equation based on where it is. And so it's a straight flat line. And for lines like that, we just call it y equals wherever it intersects the y-axis. And so if this is the origin right here, 0, 0, it's just at 1. So the directrix here would be at y equals 1. The focus is this blue dot right here, which is at 1, 2, 3, 1, 2, 3. So the focus is at 3, 3. And the vertex is this point right here where the parabola sort of changes directions. And so the vertex is at 1, 2, 3, 1, 2. Okay, you can see here that there are a few variables in the equation that we're used to, like h and k, and then there's this other one called p, and I'll talk about what that is in a minute. But h and k we can fill in right now. H still just the x value of the vertex, so 3, 2. So then the x part is 3. K is the y value of the vertex, so 2. P, this new variable. All P is the distance between the vertex of the parabola and either the directrix or the focus. And so what I can see here is that P is going to be equal to 1. Right? P is just equal to 1 because the vertex of this parabola is just 1 unit away from the focus, right? Just 1 unit away. So if I want to write the equation for this parabola, it's just going to be parts that never change. I'm going to write those in first. So x minus squared equals 4 times p times y minus k. Now I'm going to insert things. H I know is 3, k I know is 2, and p is just 1. So I can sort of simplify a little bit because 4 times 1 is just 4. So out in front here, I'm just going to put a 4. And that would be the equation in this form, what we call standard form, for the parabola graphed above. One thing to note is that, I should have said this before, but this form of the equation for a parabola is the kind we use if the parabola either opens up like this or opens down like that. What we're going to see in a second is that parabolas can also open to the left, to the right or to the left. Okay, but for parabolas that open up or down, they look like this. And then if the parabola actually opened down instead of up, p would have to be negative. So if I had the same parabola but it opened down instead of up, I would just put a negative sign right there. But since the parabola that I'm looking at opens up, I leave 4 positive. Okay, like I said a second ago, we can also have parabolas that open to the left or to the right. And so that's what this should say right here. I just made a mistake on your note taker. When the parabola opens to the left or right, the equation looks like this. And notice the only thing that changed was that I swapped y minus k and x minus h. So if I have a parabola that either opens to the right or opens to the left, the equation I use should look like this. Y minus k squared goes on one side, x minus h goes on the other side with 4p. So let's figure out what we have here. The directrix now goes up and down, and so instead of writing y equals 1, we're actually at x equals 1. The focus is this big blue dot here, so 3, 3. The vertex of the parabola itself is right here at 2, 3. And so I can fill in h and k. H is still the x value of the vertex. K is still the y value of the vertex. And the last thing I need to find is p. And remember, p is just the distance between the vertex and the focus. So just 1 unit again. So the equation here for this parabola that opens to the right, remember I'm going to put y minus k on the left side. 4 times p times x minus h goes on the right side. So k from right here I can see is 3. h is 2, and p once again is 1, and so I would have 4 times 1, and so to simplify I can just write 4 there. This would be the equation for this parabola. The last thing is if the parabola opened to the left, in other words, if the parabola did this instead of what it's doing above, and like the focus was right here and the directrix was right here, if that were the case, p would have to be negative, but since the parabola above opens to the right, p stays positive. Let's do some examples. Number 18 here says the focus is at 5, 2, and the directrix is at x equals -1. So the first thing to do is graph both of those. So I'm going to graph the focus and the directrix. Focus is at 5, 2. That means x is 5, y is 2. So there's the focus. I'm just going to put a little f there so I remember what that is. The directrix is at x equals -1. So x equals -1 is just going to be a vertical line where x is -1. So I'm going to sketch that in here. Actually, I'm just going to kind of cheat. There's x equals -1. Okay, the vertex of the parabola is always exactly halfway between the focus and the directrix. So all I have to do is figure out how far away the focus is from the directrix, and in this case it's 1, 2, 3, 4, 5, 6 units apart. So the vertex is going to be exactly halfway, which would be 3. So here's my vertex. The reason I want to find the vertex is because now not only do I know h and k, now I can figure out what p is. P, remember, is just the distance between the vertex and focus. So p here is going to be 3. P is going to be 3. I would make p negative if the directrix is above or to the right of the vertex. But since the directrix is to the left of the vertex, I'm going to leave p as a positive 3. All right, so where is this vertex? Well, it's at 0.22. So that just means that h is going to be 2 and k is also going to be 2. So to complete the left side of the equation, first I have to decide which of these two things is going to go on the left side of the equation. And so I gave you a little sort of clue here, or a little guide actually. If the directrix is y equals something, you're going to use the x minus h squared. If the directrix is x equals something, you use y minus k squared on the left side. So since my directrix was x equals something, over here I'm going to put y minus k squared, and remember k was 2. So there's the left side of my equation. On the right side, then that means I'm going to put x minus h. And remember, h was also 2. Now I just have to figure out what goes out in front here. The thing that goes out in front there is p times 4. Right? So I'm going to multiply p times 4. So I go back up here to where I found p. P was 3. 3 times 4 equals 12. And so the coefficient on the right side of the equation is going to be 12. And there's my equation for this parabola. It would look something like that. On the last one I had a focus and directrix. Now I have a vertex and a focus. So the way I go about writing the equation for this one's going to be a little bit different. First thing I'm going to do again is plot what I have, or graph what I have. And so I'm going to have to be just as careful as I can because I have fractions here. So I'm just going to try and get it as close as I can. And the graphing isn't really going to be that important here. I mean, we're going to need to do it so we can see what we're working with, but it's not vital that I get my points at precisely -9/5. I just need to approximate it. So the vertex, it says, is at -9/5, 1. So -9/5, if I did that on a calculator to see what it was as a decimal, it would be almost 2. It's actually going to be -1.8. So what I want to do, if I want to plot the vertex, is I'm going to go back almost to 2 and then up 1. So the vertex would be about right there. Focus, I'm going to put a little v there for vertex. Focus is also at -9/5, but up at 3. I'll do that in a different color so I can distinguish. Back 1.8 and then up to 3. So that's the focus of the parabola. What this tells me right away, since the focus is above the vertex, is it tells me that the parabola is going to open up, but we'll see why in a second. So I've graphed everything. What I know is that the directrix is as far away from the vertex as the focus is, but on the other side. So in other words, if the focus is up here above the vertex, the directrix has to be the same distance but below it. And so I can see here that the focus is exactly 2 units above the vertex. So the directrix is going to be 2 units below the vertex. So the directrix would be down here at y equals -1. So there's the directrix. I'm going to actually do that in a different color since that gray is not really showing up. So again, this is the directrix at x equals -1. Okay, so to find P, again, finding P is pretty easy. It's just the distance between the vertex and the focus. So 2 units. So P equals 2. And the only time I make P negative is if the directrix is either above or to the right of the vertex. But since I can see right here that the directrix is below the vertex, P stays positive. So there's P. For H and K, I'm just going to use what I know the coordinates of the vertex are. So here are the coordinates of the vertex, and so if I want to know H is the x value of the vertex, K is the y value of the vertex. So I know H, K, and P. Now all I need to know is what goes on which side of the equation. Well, since the directrix here is y equals -1, I'm going to put the x minus h squared on the left side. So I'm going to come up to this box that I've left for the equation, and it's going to be x minus h, which is -9/5 squared, equals. So then I know that y minus k is going to go on the other side. K is just 1. And then the last part is to multiply p by 4. P was 2. And 2 times 4 is 8, so that's going to be the number that goes out in front right here. And there's really only, I'm almost done. I could leave it like this, but it looks kind of sloppy to have 2 negative signs right next to each other. I know that if I have 2 negative signs in a row, they become a positive sign. And so the equation for this parabola, given this information here, would be x plus 9/5 squared equals 8 times y minus 1. And the parabola, since the focus is above, would look something like this. Now I'm going to try to graph a parabola from standard form. And so I'm looking at this equation right here, and I'm trying to figure out these 3 things. What's h, what's k, and what's p? All right, here's how I do it. I'm going to start with h. X, normally when I have the standard form equation, it's x minus h. And so the only way I could get a +1 right here is if I had x minus -1, right? So h is going to have to be -1, right? Because let me explain that again just to be clear. If I had x minus 1 there, that would mean that h was just 1, right? Because it's x minus whatever h is. The only way I get a +1 right there is if h actually starts out as a -1. Okay, so h is -1, k is whatever this number is, so k is +1. So another way to think about this is that h and k are the opposite of whatever their signs are inside a standard form. Okay, so since I have a +1 right here, h has to actually be -1. And since I have a -1 right here, k has to actually be a +1. Okay, so the signs are kind of misleading a little bit here, but just remember that when you're graphing from standard form, h and k switch their signs. P is that number that gets multiplied by 4 in this spot right here. So to find P, what I know is that 4 times P gave me -8. So if I want to find P, I'm just going to solve for it using this equation right here. Let me back up and explain where I got that equation from though. I know that 4 times P, which is what goes in this spot, is -8. So 4P equals -8. And then again, I'm going to divide both sides by 4. So P would be -2. Remember what I said about when P was negative, that means that the parabola either opens to the left or down. So when P is negative, the parabola opens to the left or down. Okay, so let's figure out which one it does. What I know is that H is -1 and K is +1. So the vertex is going to be at -1, 1. That's this point right here. There's my vertex. If P is -2, that means that the focus is 2 units away from the vertex, but down from it. So the focus is going to be down here at -1, -1. Remember, the focus is kind of like inside of the parabola. So that means that if the vertex is up here, in other words, if -1, 1 is where the parabola changes directions, then the parabola has to be coming up and then turning around like this, right? And that's consistent with what I said about P being negative. When P is negative, the parabola has to open down. If I want to graph the directrix, remember the directrix is just a straight line that's the same number of units away from the vertex as the focus is, but on the other side. And so since the focus is down here, 2 units away, the directrix would be up here, 2 units away, and it's just going to be basically a straight line like this. And so I have graphed all the important features of this parabola. If you did this on the test, even if your parabola itself is not perfect, if you can show me that it goes down instead of up, and where the focus is and where the directrix is, you get full points.